Good day! My name is Nicole Azuela, and this is an instructional video about the exercises of PCR assays as a project for the final term. The first one is volume percent. The problem is how does one prepare a 100 ml of 70% ethanol solution? The formula that we will use is percent volume is equal to volume of solute divided by volume of solution times 100. Let us first know our given and what is being asked. Here, we're being given 70% as our percent volume, and the volume of solution will be 100 ml. And what is being asked is the volume of solute. Now, let's solve it. 70 is equals to unknown volume divided by 100 milliliters times 100. Multiply both sides of the equation by 100 milliliters and divide each side by 100. This cancel out the 100 and the 100 milliliters on the right side of the equation. Then simplify. And the final answer is 70 milliliters. Therefore, we have 70 milliliters of solute inside the volume of ethanol solution. Let's go now to molarity. The problem is how does one prepare a 50 ml of 25 millimolar magnesium chloride solution given molar mass of magnesium chloride is 95.2 grams per mole. The formula that we will use is molar concentration is equal to amount of the constituent in moles divided by volume of the solution in liters. The given are the molar concentration is 25 millimolar, volume of the solution is 50 milliliters, and the amount of the constituent in moles is what is being asked. First off, because it is somewhat more convenient to deal with terms expressed as molarity, convert the 20 millimolar value to a molar value. So 25 millimolar times 1 molar divided by 1000 millimolars is equals to 0.025 molar. Now, our 25 millimolar will be 0.025 molar. We also have to convert 50 milliliters to liters because molarity is moles of solute in 1 liter of solution. So 50 milliliters times 1 liter divided by 1000 milliliters is equals to 0.05 liters. And now, our 50 milliliters will be 0.05 liters. 0.025 mole per liter is equals to unknown amount of the constituent in moles divided by 0.05 liter. As you can see, I changed the unit from molar to mole per liters because 1 molar is equals to 1 mole per liter. So 0.05 liter times 0.025 mole per liter is equals to the unknown divided by 0.05 liter. I cancelled out 0.05 liter because I multiplied it on both sides. Then 95.2 gram per mole multiplied to 1.25 times 10 negative cube mole. Let's cancel out the mole unit and the final answer will be 0.119 grams. Therefore, 0.119 grams is dissolved in a final volume of 50 milliliters of magnesium chloride. There is another way around of solving this. In this step, we will use ratios but still will get the same answer from we did earlier. First, set up a ratio to calculate the amount of magnesium chloride needed to prepare 1 liter of 0.025 molar. So, 95.2 grams is to 1 molar as unknown grams is to 0.025 molar. Multiply both sides of the equation of 0.025. Then cancel it and it will disappear, and then cancel the unit of molar and the answer is 2.38 grams. Now, set up a ratio to determine how much is required to prepare 50 milliliters and solve for x. 2.38 grams is to 1000 milliliters as unknown grams is to 50 milliliters. Multiply both sides of the equation by 50. Then, this cancels the 50 in the denominator on the right side of the equation. Then cancel the unit and simplify. The answer is 0.119 grams of magnesium chloride. Next is dilution. The problem is how does one prepare 100 ml solution of 100 millimolar ETA pH 8 from 0.5 molar stock. The formula that we will use is C sub I times V sub I is equals to C sub F times V sub F, whereas C sub I is the initial concentration of the stock solution, V sub I is the amount of stock solution taken to perform the dilution, C sub F is the concentration of the diluted sample, and V sub F is the final total volume of the diluted sample. The given are: the initial concentration is 0.05 molar, the final concentration is 100 millimolars, and the final volume is 100 milliliters. What is being asked is the initial volume. To use this approach, all units must be the same. Therefore, you first need to convert 100 millimolar into a molar amount. This can be done as follows: 100 millimolars times 1 molar divided by 1000 millimolars is equals to 0.1 molar. Therefore, 100 will be 0.1 molar. The solution is 0.05 molar times the initial volume equals to 0.1 molar times 100 milliliters. Then what will happen here is we will divide 0.05 molar to the final concentration and the final volume. This will cancel out the molar unit in both the numerator and the denominator of the equation, leaving milliliter as the remaining unit. The final answer is 20 milliliter. Therefore, you will need 20 milliliter of 0.5 molar stock solution to make a 100 milliliter ETA solution. Next is the reconstitution of primers and probes. Refer to the NMOL information provided in the synthesis report for the following custom oligonucleotides. How much volume of the TA buffer should one use to reconstitute these oligos to 100 micromolar? As we can see in the synthesis report, we have two given primers. Let us first solve the primer D1S858. In this problem, we will use the formula of volume of TA buffer is equals to amount times 10 cubed divided by stock concentration. The given are: the amount is 43.5 and the stock concentration is 100 micromolar. The solution is 43.5 times 10 cubed divided by 100 micromolar. This equals to 435 microliter. Therefore, we need 435 microliter of volume of TA buffer to reconstitute primer D1S858 to 100 micromolar. There is a shorthand method for this, where you will just move the decimal point of the given NMOL one decimal place to the right, and the answer will be the same. Let's go now to primer D11229F. The formula that we will use is still the same. The given are: the amount is 51.2 and the stock concentration is still the same as the primer above. The solution is 51.2 times 10 cubed divided by 100 micromolar. This equals to 512 microliters. Therefore, we need 512 microliters of volume of TA buffer to reconstitute primer D11229F to 100 micromolar. And again, you can use the shorthand method. The last one is scaling up or scaling down factor. The direction is: using the table, scale the reaction down to 15 microliters, Fill the table with your previous answers to guide you accordingly. Enzyme volume is 0.3 microliters. The first column is our components that are needed. Let us make another column for stock concentration in the components to make it clear. The third column is our final concentration. Let us now compute for the volume in microliters per 25 reaction. To get this, we need to divide the stock concentration to final concentration, and the answer should be divided from the 25. The enzyme is already given, which is 0.3. To get the sterile distilled water, you have to add all the components, and then the answer will be subtracted from the 25. The answer is 8.6. The formula that we will use is the scale-up or down factor is equals to new reaction volume in microliters divided by original reaction volume in microliters. Our given is the new reaction volume is 15 microliters and the original reaction volume is 25 microliters. Now let's solve it. The scale-down factor is equals to 15 microliters divided by 25 microliters is equals to 0.6. Therefore, our scale-down factor is 0.6. In the scale-up column, to get it, you have to multiply the volume for 25 reaction to the 0.6. In the last column, to get it, you have to multiply the scale-up factor, which is 0.6 to 9.